Hello, geometry folks. This is Mr. Heeren, and now we're going to kind of extend this idea of trigonometry into what are called angles of elevation and angles of depression. There are a few minor details that you need to keep straight when dealing with this, otherwise you will get a wrong answer. So be prepared to have SOHCAHTOA. And with angles of elevation and depression, you end up spending quite a bit more time with tangent than you do with the other two. But you'll still end up using all three, but you just end up using tangent a fair amount more. About kind of what we're looking at here. So an angle of elevation is simply the angle of looking up. Okay, so if you consider that there's a person down here, and you consider that there is a tree, and that there is a bird in the tree up here, the angle of elevation would simply be what is the difference between looking straight ahead and looking up? So this would end up being my angle of elevation. That ends up being my angle of elevation. Please forgive my artwork. I am very, very horrible at it, and I know so. Angle of depression, similar. So this is a little bit different. So if you imagine maybe you're on a cliff, you're standing up here, and there is water down below because that's what water looks like. So there is a boat down below. You're looking at it. So what is my angle of depression? And again, it goes from straight out. This ends up being my angle of depression. Okay, many students start using this angle, and that is wrong. Okay, that's kind of what ends up happening. Many students use this one, and that's going to be the wrong angle. So please don't use that one. So let's talk. Okay, so let's look at what we got here. So you got to think about kind of the situation, and then think about what function I might need to solve it. So we have a tree, okay, and it casts a shadow 25 feet long. And the angle of elevation from the tip of the shadow, from the end of the shadow to the top of the tree, is 64 degrees. Okay, so this is your angle of elevation. Okay, so you're starting from the ground and looking up. So now, how tall is this tree? So kind of how tall in feet is this tree? So I have an angle. I have two sides, okay? So this would be my adjacent side. This would be my opposite side. So that means I'm going to use tangent here. So this one's pretty easy. Tangent of 64, let your calculator do some mashing with that. Multiply it by 25. You end up getting 51.26 feet. And that's an answer that makes sense. So you can definitely know that you did it right, because it should be 50 feet if it's leaving a 25-foot shadow. Okay, so that's a pretty good answer. Okay. So now if we look, jet takes off and rises at an angle of 19 degrees with the ground until it hits an elevation of 28,000 feet. How much ground distance is covered in miles? Okay, so if we consider that took off here, okay, and it's going to stay there until it gets to 28,000 miles. Okay, this is going to be 19 degrees. Let me write that in a different color so it's easier to see. You're doing that at 28,000 feet, and you're trying to figure out this distance, my ground distance, right here. So how long did that take to go? Well, once again, I'm going to use tangent because this is my opposite side and this is my adjacent side. But now I must be careful, okay? Well, not quite yet. So I'm going to take the tangent of 19, then it's going to be 28,000 over my ground distance. Okay, so, and remember in this situation, all that happens is those switch places. Tangent of 19. So if I divide that, divided by tangent of 19, so I'm going to get 81,317.9. But that's going to be in feet. Okay, I need to go in miles. Okay, so to convert to miles, I divide by 5,280. Because if you remember, it tells me how many feet are in a mile. So when I divide that, that's going to be 15.4. So it's going to be approximately 15.4 miles to do that. Okay, and that's how I do it. So I'm looking at my angle of elevation, I'm looking at my height, I'm looking at my distance. That tells me to use tangent. And then after that, it's just some simple algebra, and off I go. Okay, so from the top of a vertical cliff, 40 meters high, so 40 meters high, not terribly tall, but still pretty tall. So 40 meters high, an angle of depression of an object that is level with the base of the cliff. How far is the object from the base of the cliff? Now, here's what everybody draws, and that's fine. But what you must realize is that the angle of depression is this. This is 34 degrees. This is not 34 degrees. Okay, don't put the 34 there. The 34 goes here. Remember, I start by going straight ahead and then looking down. That's where the 34 degrees is. But what I can do is realize that that's going to be 34 degrees as well. Okay, so now it becomes much, much easier to pick. Okay, so now I want tangent because it needs to know how far is this distance. So now I'm going to go tangent of 34 equals 40 over d. They switch places. So that distance becomes simply 59.3. And I can keep it as meters, and that's fine. I don't need to do any converting. Pretty simple. Easy peasy. Most of this battle is only in the setup. If you have your setup correct, then it's not too complicated. Okay, pilot sights the beginning of a runway and must approach it at a 5-degree angle of depression. The plane is 182 kilometers from the beginning of the runway. What is the plane's altitude, height in the air? So, round to the nearest kilometer. So, it has got a 5-degree angle of depression. All right, this is obviously not going to be to scale like hardly at all, so apologize for that. So it is 182 kilometers away. How high is it in the air? So what's my height? Well, if this is 5 degrees, this is my angle of depression, that means this is 5 degrees. Clean it up a little bit. Okay, so that's 5 degrees. So now I'm going to need tangent, once again, my tangent of 5 degrees, and that's going to be equal to my height over 182. So now a little bit of solving. So 182 times tangent of 5. And that gets me 15.9, but they want me to round it. So I'm going to say it's 16 kilometers away. Okay, it's 16 kilometers in the air. Okay. Next problem. Surveyor is 100 meters from a bridge. The angle of elevation is 35 degrees. The surveyor's instrument is 1.45 meters above the ground. Find the height of the bridge. So he's got his instrument here. So he's got a tripod and he's got a little thing on it. And this height is 1.45 meters, okay? That's how tall this thing is. So now he is 100 feet away from a bridge. And, meters. We're in meters, we're in metric. But the angle of elevation to the top of the bridge is 35 degrees. So now, if that's my information. Now I can do a little work here. But I just got to remember, I'm going to add this 1.45 at the end. So I want to know the height, so I'm going to take tangent of 35. That's going to be equal to h over 100. Okay, still that TOA piece. So multiply both sides by 100. Okay, so multiplying both sides by 100. Tangent of 35 times 100 is about 70.02. So that means the height is 70.02, but I also need to add in that 1.45, which brings me up to 71.47. So that is approximately the height of the bridge to the nearest tenth. Nearest tenth would technically be 71.5 or 71.5 meters. Okay. All right, so let's look at the last one here. So we've got a search and rescue team, the airlift people. They got 42-degree angle of depression. There's 18 feet above the water. What is the distance to the swimmer? Okay, so what's my distance to the swimmer? So they're dropping from 18 feet above the water, 42-degree angle of depression. So let's see what we got. We're trying to figure this out. So from here, 18 is my opposite. That is my adjacent. So I'm going to want tangent. So, and for those you might have forgotten, this is merely, this is just algebra, just moving things around using the operations. So 18 divided by the tangent of 42. So that's going to be 19.99, but you can round it to 20. So they're dropping 18 feet into the water. There's only 20 feet to get to the swimmer. That's my answer. Okay, so now you do the 6.5 assignment. And then the 6.5 quizzes. Remember, you have to get 100%. And then you move on to 6.6. All right, thank you very much. And I look forward to your questions.